Alright guys, so I have a 12 volt, 3 lithium ion, lithium ion cells, and it's 2000 milliamps, and this is a converter for 12 volts to 5 volts. This is LED lights, don't mind those. This is so motor spins 12 volts output, and this is going to be the battery that powers it. And then from here, all right, so when I spin it, it charges up the battery, and then from here it's going to be like it's going to act like a capacitor, which it has a smoothing capacitor for the input of this, which has a maximum of 16 volts, which should be fine because I'm not going to spin it that quick. And this is going to be going on the inside of there, so it's going to be the output, which it's going to turn on. But I'll be streaming everything, and I have the soldering iron on. All right guys, well, now you'll see the final result. Alright, and it's done. So the quick schematic here, I'll just draw that out. And plus I got a new camera, so you might be seeing that later if I fix my laptop. Let's draw out the schematic, and I will show you. Alright guys, so it's about 12:15, and here's the circuit that I made up in like 4 hours. So here's the motor, goes to a full bridge rectifier, then it goes to the capacitor. The capacitor charges up the battery, which the battery cannot go back into the full bridge rectifier and power the motor again because there's the diode. Well, and diode can power about 440 LEDs of 3.2 volts, 20 milliamps each, 38 watt hours output. Input is 22 watt hours. So the thing is, this does not have a higher efficiency because it's output wattage over input plus losses equals efficiency. So I wrote some losses here, which are the diodes that I use for the full bridge rectifier, which are the 1N4001, which has a 0.7 volt drop on each one, which equal to about 1.4 volts on each phase. So it's this, and wait, here's the input. Yeah, so it's this, and then Yep. This, then this. Got it. All right. So here are the things. Let's say it's about 50% because there's a broken gear inside of the gearbox. It's a geared motor, and the heat of the battery when it charges up for using the motor, because the motor has to heat up and the battery has to heat up, so it's not really the heat of the battery, it's the heat of both. So I'm just gonna say it's about 50% less efficient. So the efficiency is actually 86.3 because it takes 1.7 hours to charge. If you put the output wattage over the input, it gives us 1.7, which is watt hours, so it's 1.7 hours to charge the batteries to full. The batteries can power 440 LEDs for 1 hour of 20 milliamps each. So hey guys, that's my first prototype of this charging circuit for my phone. Alright guys, have a good day. Peace.